Hello, can you hear me? Hello, can you hear me? How do you say microphone is muted? Do you even have a problem saying microphone is muted? Oh, hi everybody, and welcome to today's algorithm challenge. So, as usual, just go to Medium and pick one. So, I decided to be a little bit detailed today in my algorithm exercise. So, I'm deciding to kind of um, also go through the rabbit hole. Like whatever problem I encounter that requires me to learn something new, I'm also going to try to learn something new on the spot, not like add it to a list because I discovered the list has been getting so full recently and might not be great to just keep doing that. So yeah, as usual, here's the timer clock. Wait a minute, clock, and then let's set up the timer for 15 minutes and let's start. So find the original array from doubled array. An integer array origin is transformed into a double array changed by appending twice the value of every element in the original. By appending twice the value of every element and then randomly shuffling the resulting array. Given an array changed, then return the original if change is a doubled array. Okay, given an array changed, return the original if change is a doubled array. If change is not a doubled array, return an empty array. The elements in original may be returned in any order. Okay, so for instance, if I give you 1, 3, 4, and 2, 6, 8. If we're given this, we want to return 1, 2, 3 because we know eventually that 1 was double to give 2, 3 was double to give 6, and 4 was double to give 8, right? Okay. So already I can see how this is an easy question or like a straightforward to reason question. So an integer array of original is transformed into a double array changed by appending twice the value of every element in original and then randomly shuffling the resulting array. So first, the array is doubled, and the items in original are like doubled and added on top of this, and then it's shuffled randomly, right? And then it's shuffled randomly. What does it mean to be shuffled randomly? Okay, and then it's shuffled randomly, but in this example, it's not actually shuffled. So yeah, given an array change, so we're going to be given an array change. Return the original if change is a doubled array. So return the original if change is a double array. If change is not a doubled array, return an empty array. The element in original may be returned in any order. I'm always on it, bro. Okay, so first of all, a solution I can think of is considering the following. Since the changed array is always going to be double of the original array, we can say we can try to sort um we can try to sort the array till we get to the midpoint. We can sort the array till we get to the midpoint, right? And then we can first split the array in two, sort both of them, and check if wait a minute. Okay, it doesn't tell us. They tell us if the integer array is what's it called? If the integer array is I don't know how to say this. Um, it doesn't tell us if the integer array is kind of sorted first. But let's take a look at the hints. If the change is a double array, you should be able to delete elements and their doubled values until the array is empty. That's a good hint. Which element is guaranteed to not be doubled? To not be a doubled value. It is the smallest element. Which element is guaranteed to not be doubled? True is the smallest element. And then hint 3, after removing the smallest element and it is double from the changed, is there another number that is guaranteed to not be doubled value? Okay, this is a different way to entirely different way to think about it. But first off, one approach, the approach at the top of my head is to first the approach at the top of my head is to sorry about that. The approach at the top of my head is to first now we don't know if it's going to be sorted, right? That's not we don't know if it's going to be 3 1 3 and we expected to have 4 2 6. We don't know if this is a possible value, right? So I think what we can do is, since we can get a double, wait a minute. Okay, so 1 3 4 2 6 8. The hint says we start from the smallest item and then find the double of the smallest item here. Okay, now this is tricky. Let's look at the hint one more time. If the change is a doubled array, you should be able to delete elements and their doubled values until the array is empty. Delete elements and their doubled values. So 1 and 2, right? 6 and 1 and 2, 3 and 6, 4 and 8. That means what am I even supposed to delete? Okay, so I can start from here and check. Now the reason this is very tricky is because even if 2 was before 4, we could say 4 is the double of 2 and kind of go wrong ways. So one thing I would say I could do is, if we try to sort this array, it's going to be 1 2 3 4 6 and 8. And no, that's not gonna work. And then the elements in original may be returned in any order, and then randomly shuffling the resulting array. Okay, so we can take the input array, find the double of 1, find the double of 3, find the double of 4. If we do that, okay, so this is easy. So we're going to loop through output. We're going to loop through original. It doesn't even give us original. It wants us to return original, right? Okay. So in this case, 1 2 3 6. I need more examples because this is I need more examples because the confusion here is that, and then and then randomly shuffling the resulting array is not guaranteed to be in a particular order, right? That's just the problem. But let's look at the hints one more time. If change is a doubled array, you should be able to delete elements and their doubled values until the array is empty. The problem with this is that you can easily delete 4 as a double of 2. you can easily delete 4 as a double of 2. That means if the array should be not ordered, you get. So will this array be ordered? That's my question. And then the second one is, which element is guaranteed to not be double, to not be a doubled value? It's the smallest element, right? Okay, so okay, what we could do is we could start at the smallest element and find a double of it. Start at the next big element and find a double of it. So we start at 1, find the double of 1, which is 2, right? Then we add 1 to somewhere. And the next is, so we've removed 2 from the array, right? And the next is 3. We find the double of 3, remove it. So the next is 4, and we find the double of 4, right? Then the next question, the next example is, find the double of 1 is not in the array. Find the double of 3 is in the array 6. So given an array change, return if change is not a doubled array. This is not a doubled array because 0, let's say the 0 really doesn't have a double, right? But let's start at 1. 1 doesn't have a double, so this array is not a double. Empty array. So input 1, 1 is not a double, so we just return 1. Empty array. So what we are going to do is we're going to sort this array. So the third hint is, after removing the smallest item, I need to double from change. Is there another number that is guaranteed to not be a double? Okay, I think I got it. First, the approach is to first sort the array in ascending order. First sort the array in ascending order. Is it descending or ascending? I don't really know. But like in this case, would have 1, 2, 3, 4, 6, 8. This is what we would have. First sort the array to this. After this, first sort the array to this. After this, or next, we want to take after this we want to take find the smallest item, find the smallest number, then find the smallest number and find the double, and find the double, eliminate both from the array, then move to the next smaller number, find the double and eliminate from the array. If we don't find a double, return an empty array. Then return the what's it called? Then return the results of the mapping. Now, let's take another example. Let's say we have this array 1, 3, 6, 1, 3, 5, 7, 9. We have this array, and then it's supposed to be 2, 6, 10, 14, 18. Yeah, 14, 18, right? So if we start at 3, and find, if we start at 1 and find the double of, and find the double 2, we start at, we move to 3, find the double 6, 5, find the double, like that. If we keep doing this, we will eventually end at a number, right? We eventually end at um would eventually end at the smallest number. Now we have to understand something. The few questions we can ask is, how do we find the smallest item in the array? How do we find the smallest item in the array? And how do we eliminate items from the array? Now finding the item in the small array is going to be using maybe some kind of reduce or some kind of I don't know, maybe some kind of reduce to find the item in the smallest the smallest item in this array, or basically we could just sort, but then the problem is that even when you sort, I think let's let this pass for a while. Yep, I know I'm out of bounds, but let's just reason together with this. So if you start from, if you order this array and you get 1 2 3 5 7 9 blah 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 blah, blah 6 also, and you get this, if you get this 9 10 14 18, if you get this, you would have to start at 1 and find the next item, right? And then, this is not going to work because you can't move indexes. So another way to find the smallest item would be, no, sorting is not going to work, would be to would be to can we maintain, let's see the topics that is involved here: hash tables, greedy algorithms, and sorting. I don't really know what to think about this, but let's try some more for 5 minutes. Let's try for 5 more minutes and see if we can come up with something. If we can't, then we'll just peep in the answers. Luckily enough, the editorials work today. Okay, so now we can start at 1 and move our point. Can we use 2 pointers? No, we can't really use 2 pointers for this. But how do we find the smallest item in the array? I think you can do that by with reduce, but that's O of n, obviously. What we could do also is to iterate through this array, and starting at 1, maintaining a pointer to not sure how to do that. Okay, so how do you find the smallest item in an array? How do you find the smallest item in an array? Yeah, this will involve us iterating through this item over and over again. There's going to be lots and lots of iterations. I tell you, there's going to be lots and lots of iterations, and I don't know if this is Mm, okay. How do we find the smallest item in the array? And how do we eliminate items from the array? To find the smallest item in the array, I can use reduce, or we can go through the item storing the map and the main. When we find the smallest item in the array, then we should find the double of this item. Then we can remove those two items from the array with slice. And after removing those two items from the array with slice, we will have an entirely new array. Um, an entirely new array. Now, this solution seems too I don't know how I would say seems like a lot, to be honest, because imagine having to loop through to find every smallest number and then loop through to find another number that is the double of that number. I mean, another solution would be to maintain hash maps. So we can start at 1 and we can start at 1. 1, the double is 2, and 3, the double is 6, 5, the double is 10, 9, the double is 18. I don't know. Maybe I'll just take a look at the editorial. Just a second to read through all this and then bring back the answer. Yeah, so I kind of figured out what I needed to do, and it was quite straightforward in a way. And yeah, so I'll just go through it. The underlying idea is that if remember I had two difficulties initially. I had the first difficulty of how do we find the smallest item in the array without like having to loop all over again, and that was where I brought up the idea of sorting and all that. It turns out that was the right way to go about this. I needed to first sort, I'll just write the correct algorithm here. I needed to first sort the changed array, and then I would convert this and then the way the solution would work is a combination of sorting and the hash maps. So after sorting the array, I want to after sorting the array, I know that the item in the first is going to be smaller item, and then the item next is going to be the second smaller item. Proceeding with that analogy, we can say we can say and then remember the problem we had before now was that we couldn't just increment the current index, right? So the way to do this is to use a hash map. The way to find out if times two of if a number exists in an array is to use a hash map. So first of all, then the next thing we need to do is convert the array to a hash map where the key is the item and value is the frequency. Key is the item and value is the frequency, right? Great. And so after I've done that, then we can iterate through the array, finding if the item exists in the array and if the 2x of this item is in the array. If both are true, we push to the answer, push the item to a new array to return. And then one important point is that we have to first check if the array is odd. Array count is odd. If the array count is odd, that means there's no way this is going to be a double of something concrete. So this is the whole algorithm for this, and I'll try to write it, and let me copy over everything here, and we can delete the rest. Okay. So first way to check if let's see, if change the length modulus 2 is not equals to 0, it's not equal to 0, then we just return an empty array. That's to test that this is an even array. Then next we want to sort this array. It's const sorted change equals change dot sort, right? And now we have sorted change, and we also need to have the lookup as an empty object, and then we can loop through for let xn changed. We can then loop through change and increment lookup let's say lookup x equals to, now I want to find a smaller lookup x, then look up x plus plus or plus 1, or then 1. This is not the cleanest. The cleanest way to do this is to say exists or exists. If it exists, look up x. If it exists, we want to say, what? If exists, we want to say look up x plus plus. Wait a minute. Look up s plus plus. Else look up x equals 1. This should sorry. Yep. So the next that changed. So we have to actually iterate through that change. It doesn't really matter, but then after this, we anticipate lookup to have that to be a hash map of all the items seen in this array. And after that, we need to iterate through the array properly for let x in sorted changed. For every x sorted change, we want to find if this item exists in the array. If look up x, if lookup x greater than 0, that means this item exists in this array. That means this item exists in this array. And then we find the 2x, right? 2 twice. If okay, then else first of all, I've not created the answer variable. I think I can create it here. Const answer equals empty array. And then if this is ever the case where it's not greater, I'll just return an empty array because it can't work, right? Greater than 0. If lookup x is greater than 0, I think we should do nothing. Wait, I don't know that yet. I think we should do nothing. If lookup x greater than 0, that means this number is still legit in this array. Then we want to find the twice of this, right? Const twice equals x times 2. X times 2 twice. Then if twice if lookup twice is greater than 0, we want to also do something, right? And then after everything we're doing now, let's do one more of this. So this is 1 3 4 2 6 8. 1 3 4 2 6 8. So first sorted 1 2 3 4 6 8 sorted. Then the lookup will be 1 2 will be 1, 3 will be 1, 4 will be 1, 6 will be 1, and 8 will be 1. So then when we are coming to iterate over this array, we start at 1 and check if is 1 in this. If it's in this, we find the double. After finding a double, if it's there, then we reduce the two of them, right? And then make it 0 and make it 0. Make it 0 and make it 0. And then for the next one, we'll find, yes, make it 0 and make it 0. And if lookup twice, okay, make it 0 and make it 0. And then look up x minus minus and look up twice minus minus. And then after this, we want to add x to the array, right? To the answer dot push x, answer dot push x. So, and then we just return answer. And let's see if this runs. Move over to here. Okay, so get 0 and 1. Why are we getting 0 and 1? Wait a minute. X 0, 1, 2, 3, 4, 5. Sorted, changed. What the hell is it? Test case 1, 2, 3, 4. 1, 2, 3, 4, 5. Is this supposed to wait a minute? Actually, also, I think what this does is to sort. Okay, so let's change this to a for loop, right? Let x equals 0. Let x equals 0. X less than sorted change to length and x plus plus, and x will start at 0. So we want to do sorted changed x, look up sorted change x, and then look up sorted changed x and sorted changed x. Now let's console.log look up sorted changed x to just see if you're on the right track this time around. Undefined, sorted changed. Wait a minute. Undefined. Of course it's going to be undefined because we need to, okay, instead of that, let's just console.log look up because it's going to be undefined, obviously. Yeah, so 0, 1, 1, 1, 3, 1, 6, 1. Yep, correct. And then we also need to change this to a for loop. X less than sorted change to length x plus plus. So look up sorted changed x and look up twice sorted changed x times 2. Sorry, x times 2. And look up twice, look up sorted changed x and look up twice, answer the push sorted change x, sorted changed x. Okay, so let's see the value of answer. It is still wrong. Something looks wrong here. Output is 135 for this. Output is 0 and 3 for case 2. Case 3. Okay, something is definitely wrong here. So here we are returning an empty array if the length is not an even number. Then we are sorting this and we are creating a lookup. To this point up looks good. And then the the actual sorting. Sorted change x greater than 0. Twice is sorted change x. Okay, so let's console log every twice. um 0 to 6, 0 to 6. Where is 6? Okay, that's because 6 is removed, so it's not going to run again, right? Because let's also see the lookup right before we start anything. Just trying to debug this efficiently. Okay, so 0, 1, 1, 1, 3, and 6. So 0, what happened to 1? 0 times 2 twice through there's 6 times 2 where we weren't saying 6 times, so that's because 6 is already the right, else. Okay, this is what we want to do. Else return empty array. So this works actually, except it turns out okay, this passes, everything works. I'm going to explain how in a bit, but first let's okay. Okay, so first we create the answer. This is what we're going to return eventually, and then we check if this array is of odd length. Then we know it's not the double of something. It simply can't work. And then after that, we sort the array and have a lookup where we're going to input all the same arrays. We want to do this for easy lookup. And then we'll look through this array to create a hash map for easy lookup. And then after that, we are looping through this array to find the frequency of this lookup or of these numbers. And if we see that the double of this number is in the array and the number is also in the array, we reduce the count of this. So if we see next time, we're not going to apply it thinking it is. And then this is what we're doing here, subtracting 1 from the actual element, and then the twice or the double times 2 elements, and then we push this item to answer. But if we can't find the double of it, then we know that this array is automatically not like a doubled array. So that's it. So then thank you guys for trying to submit. Just wait a second. Let's be sure that this works. Okay, wrong answer, like I said. So we are given this and it returns an empty array. So why could this be so? So it returns an empty array here. So if we try to sort this array, let's try to sort this array. We would have 1, 2, 2, 3. No, there's another 2. 2, 2, 2, 3, 3, 4, another 4, another 4, 6, another 6, 1 8 and 1 12. So if we were to start at this, if we were to have like a hash, this would be 1 is 1, 2 is 1 2 3. Wait a minute, I don't even need to do this. I just need to. Okay, let's do this first. 2 is 1 2 3 4. 2 is 4. 3 is 1. 3 is 1. 4 is 3. 6 is 2. 8 is 1. And 12 is 1. So what this means is what this means is when I go to 1 and I find the value of I equate it to 0 and find the double, I equate this to 3, and then I come to 2. I'm finding 2 here, and I'm finding the double of 2, which is 4. So I'm going, okay, no, wait a minute. Okay, so I start at 1, find the double of 1, 2, and then reduce them to 3, and then start at 2, find and reduce it, but then I don't find the double of 2, which is 4, reduce it to 2, and then I go to the next 2, find the, of course, 1, and then find the double of the next 2 and make it 1, and then I go to the next 2 again, of course 0, and find the double of it, 4, and of course 0, and then I go to the next, which is 3, is 1, and then I find the double of this is 6, is 6, and then I write it to 1, and then I go to the next 4, keep moving. I go to 6, I reduce it to 0 and find the double 0, and I go to 8, I reduce it to, wait a minute, I see. So this should work. Why isn't it working? Now let's go to let's add a new test case. Let's add a new test case, which is this number. And run with this test case. And you see it's failing. And one thing we can do is that we can console the log lookup. And see if it looks exactly like what we had before. It has 1, 2, 3, 1, 2, 3. 3 is 1, 4 is 3, 1, 2, 3. 6 is 2, 1 and 2. 8 is 1, 12 is 1. True. Now this part is correct. And let's see if look up twice, is there any number that doesn't have a double? Wait, console the log twice. 224. Why? What the fuck? 224. Why? Sorted change X. Are you kidding me? Why? What's happening? Is this running only twice? Eliminate sorted change doesn't. Let's know what sorted change look like. Wolf. Are you kidding me? Where's 12 coming from? Changed. Okay, let's comment this out. Okay. So definitely there's a problem somewhere. Oh wait. The sorting function. The sorting function is going to kill me, man. A minus B. Fuck. Sorting function in JavaScript. The sorting function. The sorting function. Are you serious? The sorting function. It turns out that the sorting function in JavaScript just sorts. Wait, I'm going to look. Array does sort JavaScript. The sorting function in JavaScript is quite tricky. See, you see. That's bad, man. That's bad. That's bad. That's bad. Okay. That's bad, man. Okay, so let's submit one more time. And let's see. Okay, so it works. And then thank you guys for joining today's session. I'll see you tomorrow.